This is lecture 27B in the ABCs of Communism series. You may recall that at the end of lecture 27A, we have, well, let's take it from the beginning. At the beginning of 27A, I said what we were going to do was to go over this book, Lenin's book, Materialism and Imperial Criticism, and we started on that, and we covered a couple of major points, which were that the first two-thirds of Lenin's book deal with the differences between materialism and idealism, and I suggested that that was extremely important, that you should look at it. The last third of that book, which is one of the most reprinted books in the world, Lenin's entire collection, he is the most reprinted author in the world, bar none. And the last third of that book is, regardless of which of these editions you get, deals with subatomic physics in 1908. Now, the reason was because Lenin was very concerned about the influence of Ernst Mach and his logical positivist school on people who should know better inside Russia. 5 or 6 in particular, one of whom at least was a close political ally of his. And so he saw this as a direct attack on dialectical materialism, which it was. Now, in the last third of that book, what he continually comes back to is the idea that science may in time resolve all of this sort of thing for us, because then we'll at least know what we're talking about. As he says again and again in this book, what we really don't yet know what atoms are or electrons, and of course in 1908, as you may recall, there was no agreement among physicists that there were even such things as atoms. Now, chemists had gotten used to that idea because they'd been building a periodic table in ways other than the way we do it today, but generally speaking, physicists were not even agreed on the concept of atoms or electrons. And needless to say, they didn't know anything about the subatomic particles which make up atoms and electrons as we do today. Well, in the last 100-odd years, we have definitely filled in all of those gaps. So the first lecture here was to show you that an alternative explanation for the existence of matter and energy can be offered from a dialectical standpoint. And we'd gotten up to the point of discussing the gyroscopic atom. And that atom is one that has a center, has a nucleus around which vertically traveling are gravitons that are traveling in excess of the speed of light. And horizontally around that, there are gravitons which are traveling at, there are electrons that are traveling at slightly sublight speeds and are being constrained every instant by their impact with this rotating ellipse of gravitons in a stream-like form. Now, that's why I call it a gyroscopic atom. Let's just review this a little bit more. After still more time had passed, the remaining electrons in the expanding bubble of the explosion that constituted the primordial universe that we know were captured in large part. And when sufficient amounts of this material were taken up in orbitals around atomic nuclei so that single free photons could pass long distances more or less unhindered, we often have said that the universe became transparent. Of course, there was still free particulate matter of fundamental mass particles floating outwards and around in the primordial soup. But the key point here is that the atoms, complete with electrons, had been formed at least through the first 2 elements of the periodic table, that is hydrogen and helium. Each of these atoms then looks quite different than we had previously thought, in that there are 2 rotating gimbals for each electron shell, orbital or suborbital. One, the nearly circular gimbal of electrons revolving at near light speed around said nuclei, constrained by another gimbal composed of supraluminal, that is faster than light, velocity gravitons, which itself is revolving around the same atomic nucleus in a vertical direction. I call this a gyroscopic model of the atom for the obvious reasons that the setup is exactly that of the gyroscope, with one gimbal rotating at roughly 90 degrees at its point of intersection with the other. By analogy, the subatomic nucleus is the gyroscope's rotor, and in sum we see that both rings are in motion, both appearing to be sliding around a common center. As the gyroscope holds its original position in the center of the rotor, so the nucleus of an atom holds its geometric center as a constant position relative to the gimbals. The precession of the gyroscope, that is, the way it turns over as the Earth rotates, corresponds to the overall movement of an atom as it engages in molecular formation, crystallization, or whatever other chemical effects or forms of combination it may engage in during the course of its natural lifetime. In navigational or experimental compasses and gyroscopes, adjustments are made with weights and balances to account for changes in latitude or velocity. Similar adjustments are made by outside forces on atomic structure. Finally, but certainly not least, the axle or spin axis of a gyroscope, which always points in the same direction, corresponds in the new model to the overall movement of the atom around its rotational axis, especially the rotational axis of the atomic nucleus. While we have pictured the outer gimbal as a vertical ring wherein travels a single graviton, the probability for several reasons is that it actually contains a large number of gravitons traveling sequentially, all at superlight speed, although the gimbal itself revolves around the atomic nuclear axis at slightly sublight speed. The inner gimbal we have pictured as a horizontal ring wherein travel one or two electrons. The same graviton stream, outer gimbal ellipse or ring, can only intersect the horizon gimbal of electron orbitals at 2 points, regardless of velocity of the constituents of either, and this would be the real-world reason for the Pauli exclusion principle, which is, remember, that only 2 electrons can occupy the same suborbital, although there are many possible suborbital, orbital, and shell levels in the more complex atoms. The outer ring holds the inner ring in place. On the other hand, the outer ring can be pushed at different velocities depending upon the area being circumscribed by the inner ring. Thus, the loading and unloading of photons onto different electrons in different orbitals is fixed at a maximum rate, and this is the real-world reason for so-called frequency in atomic spectra. The more tightly an electron is held to the nucleus, or in other words, the closer the orbital to the nucleus, the more rapid the rate of impact between the constituent gravitons of the outer gimbal and the constituent 1 or 2 electrons in the inner gimbal. Thus, the more rapid the rate of issuance of buffering photons, or what we've called magnetic photons, shepherded by the outer gimbal away and back again perhaps, and free or electronic photons, that those which are those exuded by contact but not shepherded away. We are getting ahead of ourselves at this point, but it is important for you to begin thinking about this real-world explanation for magnetic photons and electromagnetic spectrum photons. At this point in our story of the origin of the UDO, its evolution, and subsequently the origin of the contemporary universe in which we live, presumably there are an infinite number of other such universes, the story is far from complete. Astronomic matter has yet to be formed of hydrogen and helium, for example. But for our purposes, we shall leave the evolutionary history of our universe and go on to the analysis of photonic energy and pick up the story of star formation, evolution, and death in the 4th paper in this series. First, however, let us review the 8 essential stages in the evolution of the UDO that we talked about last time, up and through the appearance of true atoms. So, to review, all fundamental force and matter particles can be derived from one original unity particle with 2 properties, that of mass and velocity, via an 8-stage modeling of an ultra-dense pre-atomic object, or UDO. 1. In the beginning there was a great void. From a starship we would have been able to see only expanding bubbles, each a universe. these universe bubbles would occupy the void along with swarms of unity particles. Unity particles have only two attributes or properties, mass and velocity. For purpose of utility, we shall assign a mass of 1/1000th the mass of a photon to the unity particle. Remember, we have to stick with the Einsteinian principle that all particles have mass, and a speed of 1,000 times that of light as its velocity. Now, these are arbitrary numbers that I've stuck in here for purposes of giving us an idea of orders of magnitude. When agglutinated in clumps of 1,000, we say that these unity particles make up a genesis particle. 2. For reasons unknown, these particles exist. Given time, these unity particles. Given time, some will collide ever so softly, tangentially, giving two new properties to them. The third attribute is that of angular momentum, in either or both spin and flight path curvature. When the ellipse described by some of these tangentially impacting unity particles occupies a defined space, both having a common pericenter, and when 1,000 such particles ellipting around each other occupy the space of one large gluon, for example, our second genesis particle has come into existence. This genesis graviton has a structure. It is this structure which is the basis for the fourth attribute, which we first call attraction and later gravitation. Then the most tightly knit or dense part of the mass of mutually ellipsing unity particles within the genesis particle we can call the main body, and that less dense outer sphere of the particle we can call the tractor sphere. The aspect of gravitation flows from the fact that future tangential touching of these genesis particles, whose velocity, by the way, is only 1/10 of that of its constituents, since most of their collective velocity has been transformed into angular momentum, or 100 times light speed, will feature the atmosphere-like brushing of their mutual tractor spheres and the resultant ellipsing of each of them around each other, or a glue-like adherence of one tractor sphere to the other. To the degree that the former may be the case, there shall arise the inevitable fact that pericenters in ellipses have apcenters, and that in effect the outreaching ellipse has the potential of touching, holding, and shepherding other similarly constituted particles back into the range of the partners sharing a common pericenter area. 3. Ellipsing genesis particles gather in others of their same type. Eventually, in the common area, their tractor spheres shall fix each other into a larger solid, in a perfect packing we most often call entropy. Dust-sized particles become rock-sized, and so forth, until a massive and obviously ultra-dense object has been created. The packing is far tighter than a quark compacted black hole, since each of these genesis particles is simply a tiny portion of the larger unit of matter we call quarks, or electrons, or neutrinos. And since there have been no atomic nuclei created yet to fuse, composed of course of the much larger triple quark combines we call nucleons, no stellar ignition can occur. Some calculations indicate that a massive ultra-dense object would grow a distance in radii of approximately 9.5 astronomical units, which is the distance from the center of our Sun to the orbit of Saturn. However that may be, it is certain that a point will be reached when the tractor spheres of the genesis particles in the core of the UDO will be pushed back into the main bodies of those genesis particles, at which time the attraction that offsets the totally contained velocity, all of which has been converted into vibratory motion or heat, is reduced to zero, and trillions of degrees Kelvin worth of thermal energy is released and converted into explosive directional energy. However, it was not simply the core occupying genesis particles which have been transformed metamorphically by the stratigraphic separation of the UDO into definable layers. You'll recall that we had a chart on the video for quite a while last time showing all of these layers. Virtually all of them have been totally or partially deformed, that is, all of the genesis particles. In the outermost layers of the UDO, angular momentum has transformed the particles by expanding their relative volume, a function of the enormous centrifugal pressures of rotation of the UDO itself. For this reason, I have referred to these as angular momentum emphasizing genesis particles, or AMEGs, in contrast to those in the central core area, which we call mass emphasizing genesis particles, or MEGs. Now, in the center horizon of the UDO, either hemisphere, above or below the equatorial horizon that separates matter from antimatter, we would expect to see the least deformed or altered genesis particles, and these I have referred to for that reason, and because they share all properties rather than only a few or several properties, as equal property emphasizing genesis particles, EPGs. Finally, in the zones above and below the central horizon in each hemisphere, the genesis particles should be polar in their deformation, taking on attributes of both the center and the zone nearest to them on the other side of the center, giving in each case a teardrop shape. You might think of yin and yang as the way they're going to fit together. Those on the upper side of the central horizon should be larger in volume, since the layer closer to them is the expanded volume AMEGs. Likewise, those on the lower side of the central horizon should be of smaller volume, since the layer closest to them is that of the compacted volume MEGs. I call these polarly deformed genesis particles as charge-emphasizing genesis particles, or SEGs, because we want to remember that what we refer to as charge is simply a kind of polarity, or opposition of some type or another. 4. As compaction reaches the point at which the tractor spheres of enough genesis particles in the core of the UDO are pushed back into their main bodies so that they can no longer interlock, and the inevitable transfer of their thermal vibratory motion into directional velocity occurs, the Big Bang is triggered. The explosion blows the UDO apart, and the angular momentum helps. Each particle is suddenly thrown into play, and the perfect entropy is reduced in a fraction of time to zero, except for a few chunks thrown here and there and or reformed as giant clumps in the initial moments after the triggering of the final solution. I think these latter clumps are probably Professor Hawking's mini black holes. Point 5. AMEGs become singularly W bosons, and shortly thereafter some of them agglutinate to make down quarks. MEGs become gluons, and shortly thereafter some of them agglutinate to make up quarks. SEGs become singularly photons, and shortly thereafter some of them will agglutinate to form electrons. The EPGs become gravitons, and shortly thereafter some of them agglutinate to make neutrinos, and still others of them may clump in larger bodies or be blown out as clumps to act as mini black holes. Thus, we have the four fundamental force particles, as we have seen in the previous lecture, and the four fundamental matter particles, gluons being the particle carrying the strong force, W bosons being the particle carrying the weak force, photons being the particle carrying the electromagnetic force, and gravitons, the particle carrying the gravitational force, and up quarks, down quarks, electrons, and neutrinos. As they're further, each of them becomes matter particles of up quarks, down quarks, electrons, and neutrinos. Now 6. Up quarks and down quarks make up all nucleons. Two of the former and one of the latter make the proton, which we saw last time, and one of the former and two of the latter make up the neutron, which we also saw last time, and the electron added to them gives us the building blocks of all known matter, plus the ubiquitous neutrino. As time passes and the volume of the explosion increases sufficiently to reduce impact between the building block quarks to a point where they may bind under the influence of the up quarks, the nucleons are formed. and with a certain passage of time, further, the nucleons are bindable by the influence of the larger attractor spheres of the down quarks into atomic nuclei of more than one nucleon. Point 7. Helium and lithium were probably formed in this way at about this time. Around the nuclei of elements, atomic numbers 1, 2, and 3, hydrogen, helium, and lithium, gravitons would have gone into elliptical orbit as they touched tangentially the nucleons, particularly the protons. Our new picture of the atom now unfolds. At 8, all that remains is to account for the mechanism by which electrons were captured and held in orbit, and for that matter, how that occurs from that point in time to the present and will continue to occur in the future. Since all ellipses have apcenters as well as pericenters, it follows that in the travel of the gravitons making up the streams that constitute the proton-centered graviton ellipses, they may encounter other particles, including electrons, which they would then divert from their straight-line velocity. The electron exuding or issuing a photon at the point of contact, buffering the impact in such a way as to allow the intersecting graviton stream to carry off at least some of them in a shepherded direction, overcoming the inherent velocity of the magnetic photon thus acquired, at the same time as providing an angular component to the momentum of the electron. In effect, some electrons are held in nearly circular orbits as the rotating ellipse sends a graviton past the sublight traveling electron at each subsequent moment when escape might otherwise have been an object. As the electron is about to go ahead its own straight line way, it finds instead a graviton in its way and issues a buffering photon, carried away by the graviton ellipse, and has its directional velocity continually angularized. The calculus effect of this is to keep the electron constantly in a nearly circular orbit. So we see an outer gimbal, relativistically speaking, at, or in this case, near light speed, while itself composed of gravitons traveling at 100 times light speed, intersecting at roughly 90 degrees, and another ring composed of one or at most two electrons, because there are only two possible points of intersection, regardless of velocity of constituents in any two ring overlaps of this nature. As these atomic nuclei and their graviton streams took up more and more of what were previously free electronic matter, the universe eventually became transparent, meaning only that photons had a better chance of traversing it without being impacted. Point number 9, and the last one. At the subatomic level, we see a gyroscopic type of arrangement with a number of gravitons in elliptical stream-like orbits, their paranucleon being the atomic nuclei, which consisting of both W boson and gluon types of tractor spheres, is both attractive and repellent to the tractor sphere of the graviton. The electron is composed of photons, and most logically, therefore, let me see if I got the right. Yeah. Most logically, therefore, have sites for the attachment and dislocation of photons, including the exposed photonic tractors, that are also both attractive and repellent to the graviton. Thus, the graviton stream stays in place at its paranucleon and keeps in place in the de facto orbital the electrons it has captured at or near its apnucleon. The electron wants to keep going in a straight line, but cannot, as at every relevant moment its straight line trajectory is forced into a continuing angular direction by the sudden appearance of a graviton in front and then to the right of it. The graviton ellipse itself is circling or slipping around the atomic nuclei like the outer gimbal of a gyroscope, and the inner gimbal is, of course, the captured electron in its new orbital. At this precise point in space and time, where the impact would be assured if it were not for the ability and inherent necessity of the electron issuing a buffering photon, we see the real-world truth that puts the nonsense to the Heisenberg uncertainty principle, and is such a precise and important moment in space and time, and that is such a fundamental part of all matter, that we need to attach a label to it. Which I've done, but I'm going to skip over that. The graviton stream, in effect, shepherds in a slipping or clutch-like fashion the picked up magnetic photon, buffering or issuing a photon, and takes it for a wild ride. Why do we call this buffering photon a magnetic photon? Because it does explain why Faraday's experiment worked. And we'll talk about that a little bit later. But the important thing is these graviton streams shoot way up past the atomic nucleus, and they come down in the same way. If there is a circuit, if you have metal in a circuit, in particularly a coil, next to it, as Faraday demonstrated, then what you're going to do is generate electricity. Why would that be? Because these graviton streams are shepherded, that is, slip clutching, a bunch of magnetic photons with them. That is, a bunch of buffering photons with them, and they deposit them onto the electronic structure of the copper atoms, let's say it's copper, of the coiled wire that Faraday sits next to it as he's inserting the magnet in and out. What she's really doing is to increase the opportunity for the intersection of these buffering photons being carried by the graviton streams with the electronic structure of the outer copper atom electrons, and thus creating a electric current within that coiled wire. So that's why I call these buffering photons magnetic photons, as opposed to luminal photons that are just flying through space from some common emitter. The electron wants to keep going in a straight line but cannot, as at every relevant moment its straight line trajectory is forced into a continuing angular direction by the sudden appearance of a graviton in front and then to the right of it, and this is the graviton ellipse itself that is circling or slipping around the atomic nuclei like the outer gimbal of a gyroscope, and the inner gimbal is, of course, the captured electron in its new orbital. At this precise point in space and time, where the impact would be assured if it were not for the ability and inherent necessity of the electron issuing a buffering photon, we see the real-world truth that puts the nonsense to the Heisenberg uncertainty principle. I'm repeating that on purpose so that hopefully you'll get this idea of magnetism from it. And it is such a precise and important moment that I've given it a name. Now, the graviton stream in effect shepherds in a slipping or clutch-like fashion this picked-up magnetic photon, which was a buffering or issued photon from an electron, and takes it on the wild ride, which will deposit it eventually in the coiled copper wire. One possible outcome is that the photon may be carried to the other side of the graviton's ellipse to be redeposited on the electron from which it came. And this at the same time as another buffering photon is necessarily being issued by the electron otherwise to be impacted. Remember that the graviton stream that's carrying these slip-clutching buffering photons, we call magnetic photons, is moving at 100 times the speed of light, so it has no opportunity to interact at all with the copper wire itself. This also is a moment so important. Well, I've given this depositional moment on the other side of the orbital a name also, but the fact that one orbital contained only 2 electrons at any given time is now given a real-world explanation, which in this mathematical model is often referred to as the Pauli exclusion principle. Of course, there can be many suborbitals, orbitals and shells of orbitals surrounding nuclei, as we have known for a long time, but there can only be 2 electrons in any one of them. Okay, now, in this way we have reviewed what we went over last time. Now, I want to start on one other subject here which is very important. I think we have the time to go through it. It's very important because it shows you, again, the importance of Lenin's dialectics in the analysis of subatomic matter. What we have available today is the scientific proof, the data, the facts that he was hoping would be collected and in the last century has been collected. And we call this second new perspective of photons and the electromagnetic force. That's why I've called this book New Perspectives in Physics. The fundamentals of subatomic physics have usually taken light as a starting point in the centuries following Newton, as it has as it has, so we might say that particles, packets, and photons are the three P's most important to study, and in this case to restudy, or more properly revisit. The idea that light is particulate, that is made up of particles, goes back in the Western world tradition to the time of Newton, and over the years I've noticed that it's possible, I wish I spoke Chinese, it's possible that we have the same thing in China at an even earlier date, but however that may be, as far as Western world thought is concerned, this particulate idea of light goes back to Newton. At any rate, the further development of the idea of the particulate nature of light in the Western world comes in the writings of Max Planck, who proposed that the particles arrived in packets, which he called quanta. Finally, the idea that these packets had different amounts of energy was put forth and proven by Albert Einstein in his 1905 paper on the photoelectric effect. That's about 110 years ago. A great logical jump was made by the followers of these giants, namely that each of these particles, or packets, were each one photon. Packets in the process became single particles, given the name photon. Photons were then said to come in different energies. Different inherent energy levels were ascribed to different photons. To understand how this logical jump found a kind of pseudo-justification, one needs to reread Einstein's 1905 paper on the photoelectric effect. It was this paper, by the way, that earned Einstein his Nobel Prize in 1921. Einstein was able to demonstrate that when a dim blue light was focused on a photoelectric surface, that a few fast-moving electrons were produced. Further, he proved that by intensifying the brightness of the blue light, he could produce many fast-moving electrons. Conversely, on the other side of the visible light portion of the electromagnetic spectrum, that is the red side, Einstein demonstrated that the focusing of a dim red light produced a few slow-moving electrons from a photoelectric surface. Intensification of the brightness of the red light produced many slow-moving electrons. Einstein's conclusion was that blue light packets, or quanta, had more energy than red light packets, or quanta. All of this is fine, but what it led to was a central error in modern physics in the early part of the 20th century that comes to pass when subsequent thinkers assumed that these packets, or quanta, were individual particles, each of different energies. They asserted, with no foundation whatsoever, that particles, or photons, of blue light were of higher energy than particles, photons, of red light, accordingly. Because the erroneous logical jump was made by the philosophical school of logical positivists led by Ernst Mach, which brings us back to this book of Lenin's on Materialism and Imperial Criticism, because it was specifically Mach that Lenin was taking on, and at any rate, the proof offered was simply a specious circular argument, totally fallacious logically, and with no independent determination factually whatsoever to support the idea that an individual photon comes in a different set of energy levels. Rather, the circular argument hinges on the assertion that quanta are individual photons rather than packets of photons, and then the equation E equals h times the frequency nu, when h itself is a frequency value of 6.626 times 10 to the 127th erg seconds, is claimed to tell the whole story, and that is the center of the problem for the next 5 generations of physicists who simply accept the assertion. There is no proof after 94 years or 110 years that quanta arriving at the so-called high energy end of all the electromagnetic spectrum are composed of one photon. In the foregoing model of the origin of photons, there is reason to believe, and by foregoing I mean the model that we talked about in the last lecture, that there are in fact only 2 kinds of photons: those that originated in the zone above the central horizon of the UDO, and I'm talking about the matter horizon, and those that originated in the zone below the central horizon of the UDO. Why then does blue light generate fast-moving electrons and red light slow-moving electrons? I think it's obvious because there are more photons per unit time arriving in blue light than in the equivalent unit time for those arriving in red light. Or in other words, blue light quanta have more photons within them than do red light quanta. When Einstein published his 4 papers in 1905, the science of physics was still very primitive, as we discussed last time. Even the atomic theory of matter remained unproved, and although many physicists accepted it because of the periodic table, it was altogether a matter of speculation as to what an atom might actually look like, and there were many different views and models of said appearance. One of Einstein's 4 papers dealt with precisely a new form of proof for the existence of atoms, and that was his paper on Brownian motion. Thus, it is not hard to see how the confusion began over particles and packets, photons and quanta. Nor did Einstein ever accept the positivist nonsense of Mach and Heisenberg. He remained convinced to the end of his days that causality and process in the subatomic realm would eventually be proven to be as real in space and time as it is in the world in which our sensory perception evolved. It is ironic how the spectral analysis that was developing alongside this theorizing could have provided the correct insight as to the nature of light. As we shall see exactly what I mean below. It was the perversion of logic by the positivist school, dead set on proving their philosophical position for political reasons via V.I. Lenin, that resurrected the corpse of Bishop Berkeley and dressed it up in scientific clothing that in turn perverted the interpretation of spectral analysis along this road. The wrong road at the fork of decision, where one must either assume that quanta have numerous photons or that quanta and photons are the same thing. One road leads to San Jose, the other leads straight to hell. The difference in the rate of emission is what we are looking at when we look at different kinds of visible light, or for that matter, at any different category along the electromagnetic spectrum. Assuming that all individual photons from the Big Bang have long since been absorbed by electrons, then all photons now flying through space must be emitted from electrons. The only remaining question is the rate of emission. Another way of thinking about emission is to think of space between the photons emitted in a straight line from a common emitter. And a convenient analogy for this rate or spacing is phase. At what phasing are electrons from a common emitter arriving? That's the question. Hard to set a new perspective with the imposition of clarity in the way we have just reviewed. An electron in orbit around an atomic nuclei receives photons in several ways, from the stream of gravitons that hold it in space, or 2, from free light sources, that is, a photon just flying through space, or 3, from impact with other electrons. The first kind we shall call magnetic for the reasons I discussed. As I've said, the second kind is the freely traveling light-sourced photon, and the third kind is the freely traveling light. The third kind happens when atoms are heated. Their electrons bump into each other and pass photons. These are thermal photons. As the electron continues along its orbital route, it must discharge photons at a rate dependent upon the area contained within that orbital, and or vary its velocity accordingly. Thus, there is a definite determinable rate of photon emission for every atom's electrons in every orbital, given a constancy of temperature and pressure. In the pre-ionization temperature of stellar surface temperatures, such as our Sun, each element gives off a certain definable rate, photon. The rate of arrival to Earth observers, the spacing in other words, between the photons arriving from the common emitters is always the same. It is not that red photons have less energy than, say, green or blue photons. It is that they are phased in arrival more slowly than those of the green or the blue photons. At the human eye, invisible regions of electromagnetic spectrum, such as X-rays, which is most of it, the phasing between photons arriving are extreme. At the far right, there may be literally miles between the arrival of photons, radio for example. And at the far left, X-rays for example, there may be billionths of a second between arrivals. So, Now we come to the question of phase and refraction. Not only could several emissions have been interpreted, not only could spectral emission have been interpreted as proof of phasing, as opposed to different energy values per individual photon, so could refraction angle have been offered as proof of different rates of arrival in prism studies, rather than the resurrection of another erroneous concept, namely the new wave theory of light. We want to look at both of these in more detail as these papers progress, but for the moment let us move on to refraction. Spacing and rate produce a different impact pressure per unit time on the receiver. You want to think about that. This is the key to understanding the different refraction angles of different kinds of visible light and every other kind of electromagnetic radiation too, of course. Any material impacted will have a rebound rate within its own superficial molecular structure, which will vary according to the rate at which it's being struck. Let me try and illustrate that. Imagine that you have 7 trampolines side by side, standing on end, that in front of each of them is a tennis ball machine. When each machine fires tennis balls at a different rate, from slow on the right to fast on the left, we shall see that the refraction angle of the ball rebound for each is dramatically different. This has nothing to do with a different energy value per ball, for they are all being propelled at exactly the same force level in our thought experiment. What is different is the rebound rate of the stretched canvas, which must be different for each common emitter. That is, in our case here, the tennis ball firing machine. It remains only to paint each of our trampolines a different color from right to left, which are the visible lights: red, orange, yellow, green, blue, indigo, violet. You may like to remember the phrase Roy G. Biv to remember the sequence of them, but at any rate, the colors of the human eye visible electromagnetic spectrum are what we're talking about. The rebound rate is different because the material impacted, that is the trampoline material, has less time to recover from the preceding impact, ball after ball, after time. When the rate of the space between the ball arrivals, the phasing is different. Prisms, glass etchings, cardboard slit sides, or any other impacted material reacts to photons in exactly the same way. The only difference is that photons are striking individual electrons, while our tennis balls are striking many orders of magnitude greater masses of molecular structures. Thus, the angle of reflection depends not only on the angle of incidence, but on the rate of incidence. Closely spaced, rate-phased photons allow less rebound time per electron impacted than do distantly spaced, rate-phased photon impacts. Light pressure or electromagnetic pressure is different for each frequency of light, when frequency is understood to mean the spacing between photons arriving from a common emitter. It is this subatomic pressure dependent upon emission rate which is the cause of prismatic division of white light into its constituent Roy G. Biv components, and nothing more. The higher quantum energy values at the left side of the electromagnetic spectrum, say 3 electron volts, and the lower energy values at the right side of that spectrum, say 1.5 electron volts, must therefore reflect a different photon content per unit time of arrival, that is, per quanta. Nothing more. Now, the next section to this discussion I call Rule the Spectrum. If you were to lay out a diagram of an electromagnetic spectrum in a textbook and then divide it with a ruler into 1/2 inch boxes, you would be doing mechanically, or in an easily visible way, what the application of uniform quanta to said scale does in everyday contemporary quantum mechanics. There are far more spikes in the boxes to the left than in the boxes on the right when we overlay an oscilloscopic frequency trace, which again is to say that there are simply more photons in the left-hand boxes than in the right-hand boxes. I think this is something that you could do at home. You'd get out one of your science textbooks, find electromagnetic spectrum, take a pencil and a piece of paper and divide that spectrum into arbitrary 1/2 inch boxes, and you're going to see that you have far more photon arrivals in the left side than you do in the right side. Now, point number 3 here is a little bit more on electromagnetism, photons, and electrons. We know far more about the electromagnetic force than we do about any other of the fundamental forces. The others are being gravitation, the strong force, and weak force. In fact, electromagnetism is at bottom the motive industrial force of both contemporary capitalist and socialist stages in socio-cultural evolution. How ironic it is, therefore, that we know next to nothing about the actual real-world nature of either electricity or magnetism. What are the common denominators in real particle terms? And why do these particles interact the way they do? Well, the assertion that they have a common force carrier is true enough, but merely true. It leaves us nonplussed when we're called upon to explain how the photon acts in the nuts and bolts mechanics of Newtonian physics. For the very good reason, of course, that what we are looking at is far too small to see with the naked human eye or any form of mechanical assistance. It requires logic to understand causality and process in the subatomic world. In the everyday world of human productive life, under the socio-cultural conditions of the capitalist stage, it was more important to get on with the matter of harnessing energy for the continuing expansion of the means of production. These means of production are the main market, so to speak, for capitalist production, since the everyday luxuries of the few who own them and the wages of those from whom labor power is extracted to run them is far insufficient to absorb the immense surplus value being created in the process of production. For that matter, the same has been true in the transitional period characterized by both the Stalinist and modern socialist stages. The need was for a mathematical model to make both electricity and magnetism productively useful as quickly as possible, and as we all know, James Clerk Maxwell, who lived from 1831 through 1879, provided that for us in his monumental treatise, Electricity and Magnetism, first explicated in 1864 and published nearly a decade later in 1873. Not only that, but in the same work he demonstrated that the velocity of light in a vacuum should be the same, his mathematics predicted, numerically, as the ratio of electromagnetic units to electrostatic units. On the other hand, this is the point when physics as a theoretical science departed from the real-world science of Michael Faraday, who lived from 1791 to 1867. Faraday was ignorant of mathematics, and one of his biographers credits this fact with his ability to get to the bottom of electricity as a particulate phenomenon. Certainly Faraday always thought in real-world causal and processual terms. He brought the work of his mentors and colleagues into the intellectual world in the same way. When Faraday was 9 years old, about around the turn of the century, around 1800, he had gone to work, as many kids did in those days, for someone as a laboratory assistant. And it's not that man we remember today, it's Faraday, because, and this is important for us Marxists also to point out, Faraday, in other words, who made the original important discoveries in electricity, was not an ivory tower intellectual someplace. He was of a bourgeois or feudal nature. He was a worker. And in those days, as you may recall from reading the chapters on the history of the labor movement in the United States in your textbook, in those days, almost all capitalist labor was done by women and children. So it wasn't unusual for a 9-year-old to be in a factory or in a workshop. Now, he was a smart kid, and he began a series of experiments. In his initial experiments, he took a magnetized bar of iron and he stuck it next to a wire because he thought that there should be some relationship between magnetism and electricity, but nothing happened. So he fooled around with this for a while in practical terms, and eventually he coiled that wire as you would coil any wire, and then it was big enough that he could stick his magnet inside of it. Now when he did that, he got an electric current. That was Faraday's great initial discovery. The important point for us in this discussion is that there has never been a theoretical explanation for how the magnetic lines of force are transformed into electrical lines of force. Now, Maxwell showed us mathematically that we didn't need to know that in order to know what the relationship was between lines of force that are produced by magnets and electrical lines of force, which made electricity suddenly something that a capitalist could produce in a definable way, an amount, and sell. And that was, of course, what the capitalist was interested in, because he's got to find some new ways of absorbing all of this surplus value being created in these factories. The point is not that one way is a better way than another. The point is that if electricity and magnetism were to be harnessed to the needs of the capitalist age, production scientifically in the latter half of the 1800s, then it was necessary to say goodbye for the moment to the impossible mission of understanding these manifestations of the same underlying reality in Newtonian terms. That is why mathematics replaced the logic of objective understanding in physics at the time that it did. As a matter of fact, there is agreement among specialists that the definition of magnetism at the theoretical level is entirely circular. For example, this is a quote taken from the Encyclopedia Britannica 1985 edition, Volume 7, page 65. It's important to pay attention to this because the author says, magnetism, a set of phenomena associated with magnets and with moving electric charges, both of which produce magnetic fields in the space surrounding them. Magnetic fields are regions in which a force is found to be exerted on other magnets or current-carrying conductors placed in them. The circularity of these definitions reflects the fact that magnetism, at bottom, is not understood. And since 1985, the only explanation for it that I'm aware of is the one that I'm providing you in this particular lecture, with this particular model. And the point of which is not to make a great scientific contribution necessarily, but to demonstrate why dialectics is so important and why it's so important to go back and study Lenin's original book, Materialism and Imperial Criticism, and then you can come to what I call Materialism and Imperial Criticism 2.0, which is 100 years later we have all of the data that he was hoping we would get, and we can easily answer many of these questions, and we can create a model which is far more to our liking because it accounts for all of the known facts going back from the days of Faraday forward. Before proceeding with our real-world explanation for magnetism, let us continue to examine more closely the implications of our UDO model for the origin of the fundamental force particle that we call a photon, and which nearly everyone agrees has to be, the unifying force particle for both electricity and magnetism. There should be, in our model, only two kinds of photons. One kind that came from the zone above the central horizon in the UDO, the other from the zone below the central horizon in the UDO, and we're talking now only about the matter hemisphere. One is slightly larger volumetrically than the other. Photons have the unique capability, apparently related to these two forms, of combining in a distinctly perfect agglutination form to create one of the three building blocks of all matter, that is, up quarks, down quarks being the other two. The fit of the large and the small photon types diverts a sufficient amount of photonic inherent velocity. The electron always travels in a vacuum at sublight speed, though at relativistic speed. The phrase relativistic speed means at or near light speed. Now, we're coming to the end of this particular tape, so I'm going to have to stop. I think we have gotten quite a ways into this discussion. Let me just summarize real quickly. The point of this whole thing, as I've just said, and I'll say it again, is that Lenin took on Mach and the empiricists in 1908, which is what, 107 years ago, and that main point he makes in the last third of that book is that science itself may resolve all of these problems of not knowing what we're talking about, and I think you can see that it has, and that's why I thought the time had come to do a new book about, and I called it New Perspectives in Physics, and why we're doing this dialectical materialism lecture, which is Materialism and Empirical Criticism 2.0.